All right. So hopefully everything is being recorded right now, and so we did have that available here. So where I'm going here to get these notes, unlike the other 2 days, first of all, I'm going to go start in Multimedia Library as a resource and go to our current chapter, Chapter 0, and I'm a day off on assignment due dates. So tonight's assignment due is 0.2. And then to this assignment on lines is due tomorrow night or Monday night. We may need a second day to kind of talk about this and get this all straight too. But certainly you're expected to work on this beyond where we work today. Okay. So I get this PowerPoint from the Multimedia Library. It starts off, and there's a lot of objectives that this PowerPoint is supposed to be covering, and it goes on and on. But I've got basically an idea or a thought. I want to go to what's called the second objectives. It's about the first 13 slides, and then there's kind of a way I want you to think about this the rest of the video here. And that's kind of why I have maybe a little different emphasis than what the slides do. So slides will still have useful examples, but that's where the discussion, I want to take the discussion is towards things that are useful in terms of keeping all this stuff straight, which you will have to. Okay. So first objective is this idea, calculating and interpreting the slope of a line. You've seen this before. You've seen formulas and so on. What I want you to realize, every once in a while you get so into the formula and so into doing that we forget sometimes what things actually are, what things actually mean. And I hope to, from time to time, stop you guys in your tracks and get you to think of what does this stuff actually mean. So first of all, a line, you've got, think of every single one of the points that this little cross is running along is an XY pair. In fact, what this line is it's basically all the XY pairs that make a certain equation true. So that line will have an equation, and basically all the XY pairs that make this equation true are on this line. Second thing that's going on is you have this ratio, this fraction you can make by dividing how much has the line changed in an XY direction or in a Y direction, up and down, called rise, divided by how much it's changed in the run direction, in the X direction, called run. And this fraction is the same whether you pick these 2 points to make that fraction, or even if you pick these 2 points. The rise will be different, the run will be different, but the fraction is going to remain the same. The fraction is going to remain constant. And so here, I want to think a little bit about what is this about? What slope is about? Another word for slope could be steepness. It's a measure of how steep the line is. So this line is going to be fairly gentle. It's probably going to have a slope less than 1 because it's going uphill at less than a 45-degree angle. It's going to have a positive slope because it's going uphill as you go from left to right. The steeper the line gets, the higher the slope gets. The gentler the line gets, the lower the slope gets to a point. Then if it starts going downhill, slope becomes negative. And the steeper the slope gets, the more negative the slope gets. Okay? We'll have another chance in some of the later slides to see that. Other peculiarities are when you have a line that's absolutely flat, there's zero rise. The change in y is 0. Change in x is whatever it gets to be, but 0 divided by anything is 0. A flat line has slope 0. A vertical line, on the other hand, is going to have undefined slope. Why? Because you're essentially having no change in x. No change in x means down here in this equation, you're dividing by 0, and division by 0 is undefined. So this is going to produce undefined slope. So those are things you've all seen. We have this unfortunate sequencing problem in our review of math here at the college that puts lines in introductory algebra because there's people who aren't going to go on to intermediate who could still use the stuff on lines. But then we just sort of spend a semester or 2 or 3, depending on how long it takes to get through intermediate, forgetting about lines. Anyway, so here shows again the calculation. I've got these 2 points here. Change in y divided by change in x. And notice the thing in terms of the formula is they're sticking with the same point goes first. So if this point Q's y comes first in this equation, then Q's x must come first in the equation. Switch the other way around, it's okay, but it's not good to have this point's x be first and maybe this point's y be first. You got to be consistent. Okay? Okay. Let's see. So it doesn't matter the order, but only to the extent that your y's have got to be in the same order as your x's. If y is from one point, x must be from the same point. If y is from another point, x below it must be from the same point. And it is always about the change in y, how fast it rises over how fast it runs. Okay? So we go through this formula, and we take through this example here. We got the points -1, 4, and 2, -3. You find the change in y divided by the change in x. Well, in the first example, you say, hey, let's make this second point be the first point in our calculation. So its y is -3. And then we subtract the y from this point, 4. That's fine to have this y be first, but then when we're downstairs, notice this x has to be first. 2 minus -1. 2 minus -1. And that's why this becomes 2 plus 1, because subtracting a negative is always the same as adding. So this ratio comes out to -7/3. -7 divided by 3. If we do it the other way around, again, the y still have to be on top. We choose this point as our first. That's fine. So the number 4 is our first y. And then we'd subtract off -3. Subtracting -3 is the same as adding 3. This becomes +7 over -3. So these two numbers are different. They're opposites of what we're here. But in the end, the ratio, the fraction, is just a negative. -7/3. So this average rate of change, this slope, is -7/3. Now, let's look at this without seeing the graph of the line. Is this line going to go uphill or downhill as you go from left to right? Downhill. Because why? Because the slope is negative. Negative slope means the line goes downhill from left to right. Is it going to be steeper than 45 degrees or gentler than 45 degrees? For that, we got to remember what must a line that's going 45 degrees downhill. So it's going downhill and it's going at a 45-degree angle. What must its slope be? What sign, first of all? negative, -1. 45-degree angle, this is -1. Going uphill from left to right, that's +1 slope. Okay? This is bigger in magnitude than 1, so this needs to be steeper than the line with slope that's -1, so it's going to be pretty steep line. It's going to be going downhill pretty fast. Okay? And what knowing that general idea does for you, even though you probably almost never got asked those general questions before when you were taking this, in high school or in introductory algebra, the thing those help you with is they provide you with a check. So when you're calculating a slope, you can look and say, okay, does that make sense from what I know about the line? Because I can look at the graph of the line and I can know it's going downhill quickly, going downhill gently, going uphill quickly, uphill gently, it's flat, it's vertical. Those are things you can get right off of looking at a line. If you know how that's supposed to match up roughly with the slope, that's going to be helpful. Okay? So you got these slopes of lines containing the same point 2, 3, and I think we were supposed to actually calculate them. Okay? So this first line, L1, is going to have a positive slope. L2, going downhill from left to right, is going to have a negative slope. L3 is going to have slope 0 because it's going flat. L4 has slope that's undefined because it requires you to divide by 0. Okay? And the nice number 9, they actually summarize that for you. They don't summarize the less than or greater than the 1 quantity, but at least, hey, if it's positive, you're looking at a line going uphill from left to right. Negative, you're looking at a line that goes downhill from left to right. 0, you're looking for a flat line. Undefined, you're looking at a vertical line. Okay? Now, I'm not liking this. Oh, I see what they want you to do. They want us to graph these lines. Okay, they want us to add these lines to the screen. So let's check and see. This. And so what we would do with that. Okay. So if I'm graphing roughly this line, okay, which of these 6 lines did I just graph? What makes you say that?
You just said if it's at 45 degrees, it's going to be 1.
Yeah, so it's by 4 or line y equals -x. Good. What? Let's see if we can get a pen color change. Which one of those lines could the green line be? 5 or 6, yeah, because it's going downhill and it's going downhill fast. And finally, this one, oopsie, it didn't change my color as much as I wanted. This one has pretty much got to be what? 2 or 3. Okay. And what's coming from that, by the way, then, is a memory that some people might not remember, just to remind it. This number in front of the x, when you've got y equals so many x, or even y equals so many x plus something, when it's set up with y all alone on the left-hand side and so many x plus something on the other, the number in front of the x, the coefficient of x, is the slope. So in this case, we had a slope of -1/4 and -1/2. That points to being a gentle line. Here we had a slope of -2, a slope of -6, points to a steep line. Y equals -x implicitly means y equals -1x. That implies your 45-degree angle going downhill. Okay. And so there, sure enough, is how they go about it. Okay. Objective 2, this is going to be the last objective I've covered directly off the slides. And then I go to make a point about the rest. The rest of the slides will be good stuff for you to look at and study. But there's an important point to be made about this here. So graphing a line given a point and slope. Okay? And so we're just given an example here. And here's the deal. Graphing a line. They aren't looking right to the equation just yet. So graphing a line given a point and slope, what we're dealing with then is we've got a point 1, 4. And in the case of A, we've got a slope 1/2. What that means is if we start from this point and go up 1, out 2, up 1, rise of 1, run of 2, 1 divided by 2, or we could go backwards, rise of -1, run of -2. Sometimes the way we have the graph written out, that's just an easier point to get to. Says, but the rise is 1. Well, no, the ratio of rise to run is 1/2. You can make the rise equal -1 and run -2. You can make the rise 2 and the run 4, just as long as that ratio is okay. Oopsie. And then you can, that's connect the dots to get the line. Okay. Similarly behaves with 3/5 as a slope. Okay. At this point, I want to stray from these slides. These slides are great, and they'll have some good stuff in it. But I want to go to a theme here. Okay, so I'm going to escape from this. Let's discard the ink. And go into, it's not Notepad, it's Paint is where I wanted to go. To have just a blank sheet to write on. What a lot of section will be is problems of varying length and difficulty that begin with the expression, find the equation of the line. At this point, yeah, I'd suggest if you aren't taking notes right now, this is a good point to take some notes because you'll want to get this point down, this whole business down as far as we go. Okay? Find the equation of a line is how it always starts. How it finishes will look wildly different. It may be find the equation of a line containing these 2 points. It may be find the equation of a line that contains this point and this slope. It may be find the equation of the line that contains this point and is perpendicular to this other line. It may be find the equation of a line that contains this point and is parallel to this other line. There's all these different things that begin with that expression, find the equation of a line. Your ability to make progress on these problems, your ability to do these problems is going to be dependent upon your ability to read them for what they actually are supposed to be saying to you. Okay? And so reading them is a matter of realizing that once you see this expression or anything that says basically the same thing, you get some needs in order to be able to solve it. If you have a slope and you have a point, you have all that you need in order to find that equation that all the points on that line make true. That every time you pick a point that's on that line, put its coordinates into the equation, it comes out being a true statement. If you have a slope, you have a point, you've got what you need. So when you see this, find the equation of a line that begins with this, contains this point, does that, does the other thing, you need to stop and ask yourself, okay, what's the slope of this line they're getting at? And do I know at least one point that's on this line that they're getting at? So let's pick an example, probably the most basic example. Find the equation of the line with slope, and I'm going to reintroduce you to the letter M as a shorthand for slope, and containing the point 2, -1. We're going to find the equation of that line. And we've got a rule or a kind of a formula that helps us. That is the point slope form of the equation of a line with slope M and containing point x1, y1. So if I know coordinates of point and I know a slope, I have an equation of a line. It goes as follows. I write the letter y minus y1. So I've got just the letter y minus whatever this y of the point is, equals m, parentheses are important here, times the quantity, just letter x, minus x of the point. So in this example right here above, our equation is going to be y minus, the y of this point is -1, equals our m, our slope is 2/3 letter x minus the x of this point is 2. So if you're just asked for an equation, boom, you're done. Usually, however, they want it in another form. Most common form is that slope-intercept form I mentioned earlier, where you have y all by itself and the other terms on the other side. So let's rewrite this a little bit. This y minus minus 1 becomes y plus 1 equals, and let's distribute through to remove the parentheses, 2/3 x. 2/3 times -2 is 2/3 times -2/1, right? Equals -4/3. Okay. So what I can do is I can subtract 1 from both sides to get y all by itself. 2/3 x minus, well, 1 minusing 1 can be the same as -3/3, right? So this is -7/3. And there is this equation in slope-intercept form. There are other forms that you'll see. I'll have you check the notes, the PowerPoint notes and the text for those other forms. I'm going to do these all going to slope-intercept because that's going to tend to be the most common one we use, especially when we want to express lines as what are called linear functions, okay? So, well, that's obvious then, of course, if I use something called point-slope form, that all I need is a point and a slope. But what if I'm starting with something other than, what if I want to go somewhere else? Let's look at some of the other possible examples that could be out there. Example. Let's find the equation of a line containing these 2 points. Now remember my little scoring system for homework. That's what I'm going to be referring to here for a second. The 0-point response, well, one 0-point response is just write down the darn equation, not show me how you got it. Another 0-point response would be to say, well, shoot, they don't give me a slope. I need a slope and a point. They don't give me a slope. I give up. A 2-point response would be to realize, okay, I need a point. I can pick either one of these. I'm going to go with 2, -1. I could just as easily have picked -2, 3. Boom! 2 points out of 5. Because you sat there and you looked at this and say, okay, there's something I need out of this equation. I need to find a point. I need to find a point and a slope. So here's the point. But now we also need a doggone slope. Oh, wait a minute. Wait a minute. I can just calculate the slope. So I have y minus y So this is my first point, right? So -1 minus 3 divided by x minus x, 2 minus -2. This is -4 over 2 plus 2, which is 4. This has a slope of -1. Okay, so now I know a point, and now I know a slope. Dr. Artie says that's all I need to be able to find the equation of the line. I take it back to the point-slope form of the line, y minus the y of our chosen point. We decided 2, -1 is going to be our chosen point, equals m. Our m in this case is our slope, -1, times x minus the x of this chosen point. So we've got y plus 1 equals -x plus 2. Subtract 1 from both sides. My slope-intercept form is y equals -x plus 1. Okay? So maybe that's not what you get. Maybe what you get is something like, example, find equation of a line. Parallel to. And containing. Parallel to something and containing. Okay. First thing we want to realize, you got two lines that are parallel. Maybe they look like these two. Maybe they look like these two over here. So there's these two examples of pairs of parallel lines. Let's just look at this one in the upper corner first. If the slope of this longer line segment is 3, what do you think the slope of the upper line segment has got to be? 3. Because slope, in our little common sense version of it, has to measure how steep lines are. If two lines are parallel, they have to be just as steep as each other. So they have to have the same slope. Two lines that are parallel have to have the same slope. So what we know is that our slope is the same as the line 3x minus 2y equals 6. But we have to do some work to figure out what that is. Some people want to say, oh, 3's in front of the x, therefore my slope is 3. But that only works if you're in slope-intercept form. So we have to go there. We have to get y all by itself. Get y all by itself. So the first piece of clutter we can get rid of is the 3x. And so I've got -2y equals -3x plus 6. And then to get y completely isolated, I can divide by -2, but I have to divide the entire side by -2 over here. I've got y equals -3 divided by -2 is +3/2. Where is my little back? Here we go. +3 halves x. Positive 6 divided by negative 2 is negative 3. There is, now, it's the same as this line. And a lot of people say, oh my God, I've got an equation in slope-intercept form, I'm done. But that's not quite the case. This line is not the line we're interested in. It's just the line with the same slope. It's the line with the same slope. So we got to do more work. So all we've gotten out of all that work is to realize our slope is 3/2. And if our slope is 3/2, then our point contained, well, it's the only point we have, so our point is 5, 4. We can go off into point slope form. Say y minus the y from this point equals slope times x minus the x from this point. Y minus 4 equals 3/2 x minus 5, assuming we want to go to slope-intercept form, which I've said for today's discussion, all these things go to slope-intercept form. I'm going to add 4 to both sides. And then I get y completely by its lonesome. Y equals 3/2 x minus 1. 3/2 x minus 1. This is the equation of a line parallel to this, having the same slope as this, and containing 5, 4. I want to just let the last 10 minutes of this class to let this settle in your pretty little heads. No more lecture. You may at home are more than welcome to start your work on this assignment for section 0.3 and on the paper problem for 0.3. You have enough information. We'll also take some time on Monday to work. We'll talk about perpendicular lines because that's another instance that comes up. And we'll talk about strange ones that don't have X or don't have Y. We got to talk about that case. But you can also read about that too. So you're welcome to get started on 0.3, or you're welcome to just let this soak in. All right. Have a great weekend. I will see you on Monday.